Hello everyone, my name is M. Ganesh and I am here to discuss some important OS concepts today. Operating system. First of all, an operating system is system software that acts as an interface between hardware and software. It manages computer resources efficiently and provides an environment for applications to run. First of all, we want to discuss about key OS functionalities. It includes, first of all, process management. It handles the creation, execution, and termination of processes. It also manages CPU scheduling and synchronization. Next, memory management. In memory management, it allocates and deallocates memory for processes and prevents unauthorized access. And third one is file system management. In file system management, it manages files, directories, storage, and access permissions. Next includes device management. It controls hardware devices, which includes printers, disks, keyboards through device drivers. And next one is security and access control. This functionality protects system resources from unauthorized access, ensuring that data and user privacy are maintained through various security protocols. And it protects against unauthorized access using authentication and encryption. Networking and communication. In networking and communication, it supports communication between devices over networks. And our next concept is user mode. Usually, user mode is a restricted execution mode where applications run with limited access to system resources. The main characteristics includes applications cannot directly interact with hardware. They must request services via system calls. Memory access is limited to prevent interference with system processes. It crashes in user mode do not affect the OS. Example, running a web browser, text editor, or media player operates in user mode. And next concept is kernel mode. Kernel mode is a privileged execution mode where the OS kernel has full access to system resources. It includes the following characteristics. Kernel code can directly access hardware components. It executes critical operations like process scheduling, memory management, and device control. A crash in kernel mode can lead to a system crash. Examples include device drivers, process scheduling, and memory management routines run in kernel mode. Next, we are here to compare user mode and kernel mode. First of all, there are mainly it includes features like access level, hardware interaction, system calls, security, and um, first of all, user mode. In user mode, access level is restricted, whereas in kernel mode, access level is fully accessible. And hardware interaction, there is no hardware interaction in user mode, whereas in kernel mode, there is an hardware interaction. And user mode requires system calls, whereas kernel mode does not require system calls. And the security is high and restricted in user mode, whereas the security is low and privileged in kernel mode. User mode has examples include applications like browsers, whereas the examples for kernel mode includes OS kernel, device drivers, etc. Next concept is compiler and phases of compiler. First of all, what is a compiler? A compiler is a program that translates source codes into machine code so that the computer can execute it. There are various phases of a compiler. That is, first of all, lexical analysis. It converts the code into tokens. Tokens are nothing but the smallest units. Next, syntax analysis. It checks for code for proper structure, which includes grammar. Next, semantic analysis ensures code has meaningful logic or not. And next one is intermediate code generation. It converts source code into an intermediate representation. And fifth one is optimization, improves efficiency by eliminating redundant code. Next one is code generation. It translates the intermediate code into machine code. And the final one is linking and assembly. That is, it combines code and dependencies to create an executable file. And the next one is interpreter. An interpreter is a program that translates and executes code line by line rather than compiling it into machine code first. Mainly, the compiler and interpreter are different. Interpreter is based on line by line, whereas the compiler compiles the entire code at first. The characteristics of interpreter: it is slower execution than compiled programs, and it is useful for debugging and scripting. And there is no separate executable file is generated, and it works interactively. Example Python REPL. and it includes examples like Python, JavaScript. These languages uses interpreters. Bash shell scripting also interpreted line by line. Our next concept is Java Virtual Machine, which is an acronym for JVM, and how it works. First, JVM is an acronym for Java Virtual Machine. The Java Virtual Machine is a software-based engine that runs Java bytecode on any platform, making Java platform independent. Working of Java JVM includes compilation, class loading, bytecode verification, execution engine, garbage collection. Compilation. Java code is compiled into bytecode, which is saved as .class files. Next one is class loading. Bytecode is loaded into memory. And the next one is bytecode verification. It ensures security and integrity. And the next one is execution engine. Converts bytecode into machine code. That is just in time compilation. JIT. Next one is garbage collection. It manages memory by removing unused objects automatically. Next, also it includes JVM components. There are mainly three JVM components. First one is class loader, second one is runtime memory, third time is execution engine. Class loader, it loads Java classes into memory. Runtime memory, it includes the heap stack. It manages memory allocation. Execution engine, it runs bytecode efficiently. For example, running a Java program, Java my program executes it inside the JVM, ensuring platform independence. Thank you.